Hello everyone, welcome to HC Tutorials, and we are continuing with our free body diagram lessons. Okay, let's say we're asked to draw a free body diagram of a box being pulled upwards on a rough inclined surface. We know that the word rough means there is friction. Okay, so usually when we draw our free body diagrams, we start by drawing our force of gravity, which is acting downward, which is the what? The Fg. And next we draw what? We draw our normal force. Okay, but notice that we cannot draw our normal force like this. Why? Because the normal force, it is always or must be always perpendicular to the surface. Okay, and this one that we just drew, it is not perpendicular to the surface, so we must make it perpendicular to the surface. And how do we do that? We will draw our normal force like this. Make sure that it's straight and perpendicular. Okay, and this is our normal force. Okay, so now since our plane is at an angle, when we look at our horizontal forces, we will be looking at forces that are around this place. Okay, and when we look at our vertical forces, we'll be looking at forces that are around this place. Okay, sorry about that. Okay, so since we'll be looking at forces around these planes, can you see that our force of gravity is not aligned, or it is out of those two planes? Okay, what does this mean? This means that we should break it down into two components. Okay, and how do we do that? Since our force of gravity is going down like this, okay, there is a force going like this. We break it down into two components, and the first component is going down like this, and we call this component what? Fg perpendicular. Why Fg perpendicular? Because this is our surface and it is perpendicular to that surface. Okay, again, we said we will break it down into two components. The next component, it will be going down like this, and we call this component Fg parallel. Why do we say it's parallel? Because this is our surface and it is parallel to this surface. Okay, so now these two forces that we have, the Fg perpendicular, it is always equal to mass multiplied by the acceleration due to gravity cos of theta. Okay, that's why you hear people calling this mg cos theta. Okay, and this other force, which is the Fg parallel, or force of gravity, the parallel force of gravity component, it is equal to the mass multiplied by the acceleration due to gravity sine of theta. Okay, so now instead of drawing, when we draw our free body diagrams, instead of drawing this force of gravity, now we're going to say we start with our what? We will start with our box, representing it with a what? With a dot. Okay, then we go with, we know that we can see that we have our force applied. We can draw our force applied going at that direction. Okay, we know that we also have a normal force. we draw our normal force like that, as we can see. Okay, they say that the surface is rough, so we know that we're going to have some friction, and this box is being pulled upwards. It means our frictional force will go downward. Okay, our frictional force should be shorter a bit. Okay, sorry, should be a bit short. This is our frictional force, this is our force applied, and this is our normal force. Okay, so instead of drawing our Fg going down like this or about that, we will represent it by the two components, which are the Fg perpendicular, which is going like this. Okay, we name it Fg perpendicular, and also the other one, which is Fg parallel, which is going like this, and then we name it Fg, and that is your free body diagram. Okay, I know this may look confusing, but it's not. You just have to repeat until you get it, and do more examples. Okay, so now, what is our horizontal net force? Okay, let me erase that. What is our horizontal net force? Okay, we said when we consider our horizontal forces, we'll be looking at what? Forces around this plane. And now we're going to say our net force equal to, let's look at that plane. We have the applied force, which is our Fa, okay? But now, because these forces are going into the other direction, we can say plus, what is this? Our frictional force minus our Fg parallel, because it is at that plane. Fg parallel, okay? And this frictional force, we know when you substitute, make sure that it is going into another direction. So I can just erase this part here. Make sure that when you put your frictional force, because it is opposing the motion, it will be negative. And then this is going to be your net force. Okay, and so that's it for today's lesson. Please subscribe to our channel. If you have any question, any comments, just put it down the comment section. Thank you so much, and see you again when we do our examples. Sharp sharp.